Students, now we are going to start combustion and flames. First, I am going to give you the set of videos so that you can understand what exactly is the chapter about. Then I am going to give you the expression part of the textbook, which will be followed with my explanation so that you can gain the knowledge in both the ways, like perfectly. Okay, so watch these videos again and again so that you understand them in the first attempt only. Thank you.
Hello friends, this video on combustion and flame part 9 is brought to you by examfear.com. No more fear from exam. So now that we have understood the concept of combustion, let us talk about the different types of combustion. So here we are going to discuss about 3 types of combustion, that is rapid combustion, spontaneous combustion and explosion. So these are the 3 combustion which we are going to discuss. Now let's start with rapid combustion. Rapid means something which happens very fast. Rapid is fast. So in this type of combustion, a substance gets burned very fast, and during the process large amount of heat and light are produced. So heat and light both will be produced. So the best example to understand rapid combustion is the gas stove. Now when you switch on the knob of your gas oven and you bring the matchstick near it, what do you see? Even you do not need to touch the matchstick with your oven. You just bring it near it and it catches fire. So the gas stove lit immediately. So why it catches fire? So this type of combustion where it happens very fast. So the process of combustion got initiated very fast. It did not take a lot of time. And as a result of combustion, heat is being produced. Of course, the heat produced is enough to prepare your food, to boil your food, and also light is produced. So you can see the presence of light here. Yes, so this is one example of rapid combustion. Again, in this case, you see that an external ignition source is needed. So when you took this example of the gas stove, what was the external source? External source was the matchstick, because you need a burning matchstick or a gas lighter to ignite it. So for rapid combustion, you will always need an external source to ignite that particular substance. You take example of combustion of petrol. So in petrol or diesel, there also you need some external source. Maybe again you think of a burning matchstick. As soon as you bring it near in the vicinity of petrol, it immediately catches fire. So that is rapid combustion. Heat is produced, light is produced, and the combustion process happens very, very fast. Now, explosion is very closely associated with rapid combustion. So it is basically like rapid combustion, but here other than heat and light, sound is also produced. So this combustion is accompanied by heat, light as well as sound. So the best example of explosion would be the firecrackers. So during Diwali or any other festival, you often fire the crackers. So you see, they produce light. They also produce a lot of heat. So when you stand near them, you actually can feel the heat. And at the same time, they also produce a lot of sound. Even the bombs, they are also examples of explosion, because there also combustion happens and heat is produced, light is produced, and sound is also produced. So that is explosion. And the third type is spontaneous combustion. So here there is sudden ignition of a substance on its own. So here no external source is needed. So the substance will ignite on its own. So that is why it is called spontaneous. Spontaneous means sudden, anything that happens suddenly. So here you do not have any matchstick, nothing is required. The substance will catch fire on its own. So the one example is phosphorus. So we know that phosphorus is highly reactive in presence of oxygen, and that is why it is not even safe to store it just like that. It cannot be kept exposed to air, then it will catch fire. So how do we store it? We store it inside water, because phosphorus does not react with water. So phosphorus is one example of spontaneous combustion. Here there is no external ignition source needed. So for phosphorus to catch fire, you do not need to do anything. It will on its own catch fire. The other example is the coal fires. Now, I was talking about the coal fires some time back also. Now, coal is formed from the dead plants deep down the earth. So, in fact, the formation of coal happens under the influence of high temperature and high pressure. Now, there are thousands of coal fires which are burning around the world. Some of them are even difficult to locate because they are deep down underground. Some of them can never be extinguished because the coal fires it has spread so much. So under the effect of high temperature, as I told you that coal has an auto ignition temperature of around 500 degrees Celsius. So if you talk about coal, they have auto ignition temperature of 500. That means if you heat coal to a temperature of 500 degrees Celsius, they will get ignited on their own. So that is what exactly happens in the coal mines, due to which these coal fires take place. Now when the temperature increases too much there, so the coal catch fire, and that is an example of spontaneous combustion. So the most important difference between rapid and spontaneous combustion is that in rapid combustion, external source is needed. In spontaneous combustion, the substance undergo combustion on its own. No external source is needed. Other example is the forest fires. You would have seen that in dense forests, they often catch fires on their own when the temperature becomes very high. So they are also the same thing. When the temperature increases too much, what happens is plants tend to catch fire. In fact, if you compare it in this way, if you have a green leaf and if you have a dry leaf, it is easier to burn the dry leaf. The dry leaf catches fire easily because the green leaf has a lot of water. So as long as you have water will try to keep the substance cool. Therefore, the leaf will not be able to reach its ignition temperature. But in case of a dry leaf, water is not there. So it will reach its ignition temperature quickly and it will catch fire easily. So in case of forests also, normally forest consists of trees and trees have moisture in them. But when the weather becomes very, very hot, then what happens? All the moisture gets evaporated. So there is not much water left in the trees. So they become very dry. And in such situation, it becomes easier for them to reach their ignition temperature when the temperature in the surroundings is very high. And once they reach their ignition temperature, they can catch fire. So forest fires which happen in this way is also an example of spontaneous combustion because it happens suddenly on its own without any external ignition source. Thank you. Please visit www.examfear.com to watch more educational videos with a better experience. Please do not forget to like and subscribe to our YouTube channel for latest updates. Thank you once again. Hello friends, this video on combustion and flame part 8 is brought to you by examfear.com. No more fear from exam. So now that we know about auto ignition temperature and flash points, we see that there are certain combustible substances which can burn even more easily because their ignition temperature is very low. So such substances are called inflammable substances. They can catch fire very easily. Why? Because they have very, very low ignition temperature. So basically you can say that inflammable substances are those combustible substances which have very low ignition temperature. So in a way, all inflammable substances are combustible. But all combustible substances are not inflammable because there are many combustible substances which have relatively higher ignition temperature. So let us look at some examples of inflammable substances. So the first example is that of petrol. So if you look at petrol, it has an auto ignition temperature. What is the auto ignition temperature of petrol? It is 232 degrees Celsius. And the flash point of petrol is minus 65 degrees Celsius. So this is the auto ignition temperature and this is the flash point. So if you see, auto ignition is quite high. So that means petrol cannot catch fire on its own very easily because it has to be heated till to a temperature of at least 232 degrees Celsius. But if you look at the flash point, it is extremely low. So even at room temperature, it can very easily catch fire if there is a source of ignition. So petrol is an inflammable substance. Let us look at the next example of LPG. So in case of LPG, if you look at its auto ignition temperature, so the auto ignition temperature is in this range around 410 to 580 degrees. So this is the auto ignition temperature. So it doesn't blast on its own suddenly. It has to be heated to this high temperature for that. But if you look at the flash point, again it is very low. It is minus 104 degrees Celsius. Just see, these are all in the negative range. So at room temperature, they are actually going to blast if there is a source of ignition. That is why you would have seen that it is always advised to check that your gas burner knobs are kept off when you are not using it, because if it is kept on, basically your LPG is going out of it. So your LPG is present in the atmosphere. So whenever it finds an ignition source, maybe through a matchstick or through a gas lighter or maybe through a bulb, so wherever it finds a little bit of heat or a little bit of source of ignition, it gets ignited and there will be a huge blast. You can take other examples also, for example, alcohol or diesel. So even they have very low values of flash points, somewhere around 16 degrees Celsius for alcohol. For diesel, it is around 52 degrees Celsius. So that means they are all examples of inflammable substances. So alcohol is also an inflammable substance. Diesel is also an example of inflammable substance. So such substances with extremely low ignition temperature so that they can catch fire very readily, they are called inflammable substances. So now that we have understood the concept of how objects catch fire, so let us try to understand in more detail how exactly a matchstick catches fire. Now we saw that friction plays a very important role in igniting a matchstick. Now, before talking about the physical processes, let us talk about the constituent of the matchstick. What is present in the matchstick? So the most important role in ignition of a matchstick is played by phosphorus. So phosphorus plays the leading role. Now, why is phosphorus an important constituent of matchstick? That's because of extremely reactive nature of phosphorus. So if you remember when we were discussing the lesson on metals and non-metals, I told you that phosphorus is an extremely reactive metal. So if it is left open, exposed to air, it catches fire. So it readily reacts with oxygen to catch fire. So that is why how do we store phosphorus? It is generally stored inside water because phosphorus doesn't react with water. So this phosphorus is an important constituent of the head of the matchstick. So here you have phosphorus. So now there are two types of phosphorus which exist. One is white phosphorus and the other one is red phosphorus. Now white phosphorus ignite even more spontaneously in air, and it is also unstable and very much volatile and sensitive. So that is why instead of using white phosphorus directly, these days red phosphorus is used in the head of the matchstick. So this is red phosphorus, and white phosphorus is extremely harmful also. So considering all these advantages and disadvantages, red phosphorus is used as a constituent of the head of matchsticks. So it is not only phosphorus which is present in the matchstick. Along with red phosphorus, we also have small amount of potassium chlorate and sulfur. So potassium chlorate is KClO3. This is also present, and sulfur is also present in small amounts. Now, why do we have all of these together? That's because the purpose of phosphorus is to initiate the ignition, because phosphorus is extremely reactive. So it can cause the ignition. But now that ignition happens, but then it will stop immediately. So in order to have the ignition for a longer duration, that is why we have potassium chlorate and sulfur. So we will see that potassium chlorate helps in releasing little more of oxygen, and that oxygen will combine with the sulfur to again cause ignition, because sulfur is also very reactive. So when it gets some extra oxygen from potassium chloride, so it reacts with that oxygen and again it helps to retain the ignition. So that's how the your matchstick remains ignited for a longer time. So that's how the entire process happens. So these are the constituents of your matchstick. So now we will look at the entire process in more detail, step by step. So this is a recap of the entire process. So as I said, phosphorus plays the most important role. Which type of phosphorus do we use? We use red phosphorus, as you can see here. Now the head of the matchstick looks little more red, so that is also because of the artificial color which is being put there, but otherwise red phosphorus is present here. Now what is the first thing that we do if we want to ignite a matchstick? We strike it. When we strike it, what happens? There is friction, and friction produces heat. So heat is produced. Now once this heat is produced, what happens? The red phosphorus gets heated up. So when it gets heated up, it gets converted into white phosphorus. So some red phosphorus will get converted into white phosphorus, and white phosphorus, as I said, is extremely reactive. It is extremely volatile. So this white phosphorus will immediately react with the oxygen which is present in the surroundings, and a lot of heat will be generated, and we will see the ignition. So we could see the flame in the matchstick. So now the huge amount of heat that gets generated, so this heat is sufficient to break down potassium chlorate. Now as I said, potassium chlorate is also present along with red phosphorus. So what happens? This potassium chlorate, that is KClO3, potassium chlorate, it acts as an oxidizing agent and it releases oxygen. So due to this heat which is generated due to the reaction of phosphorus with oxygen, so the heat will break down potassium chlorate to release oxygen. So as a result, oxygen will be released. Now when this extra oxygen gets released, the sulfur, the small amount of sulfur which is present there, that quickly reacts with this oxygen to form sulfur dioxide, and during this process again a flame is produced. So that's how the flame which was initiated by this phosphorus, because here also the phosphorus basically reacted with oxygen to form phosphorus pentoxide, and during this process the fire was initiated or the flame was formed. So that flame was retained for a longer time due to the reaction of sulfur with oxygen. So from where did the sulfur get the oxygen? From potassium chlorate. So that is why we have potassium chlorate and sulfur in addition to phosphorus. So this is how exactly matchstick is ignited. Thank you. Please visit www.examfear.com to watch more educational videos with a better experience. Please do not forget to like and subscribe to our YouTube channel for latest updates. Thank you once again. Hello friends, this video on combustion and flame part 11 is brought to you by examfear.com. No more fear from exam. So let us look at the structure of a flame. So if you closely observe the flame of a candle, you will see that it is not a one-layered structure. So if you look at it from far away, it just looks like a yellowish orange structure. But if you observe it closely, you will see that the centermost part of the flame is kind of blackish in color. So this part of the flame is little blackish in color. If you look at the center part, that which is majority of the part, that looks yellowish in color. And if you closely look at the outermost part, the outermost layer, it is slightly bluish in color. So based on this, the structure of a flame is divided into 3 layers. Now, so as I said, this one is the outer zone, this is the middle zone, and this is the innermost zone. So these are the 3 zones basically. So all you need to do is take a copper wire or maybe any other metal wire. Just put that wire in such a way that this part of the wire is in the middle zone and only this part of the wire is in the outer zone. And you are holding the wire from here. Now keep it this way for some time, and after that observe what happens to the wire, and you will see that only this part of the wire becomes maximum hot. So this part becomes red hot. So what does that prove? That proves that this portion of the flame is the hottest, because inside it was not that hot. So inside this part did not become red hot, but this part was the most hot. So this proved that the outer zone has the highest temperature. So now if you look at the 3 zones of the flame, So you will find that the outer zone is not color wise, the outer zone is bluish in color. Now when you look at it from far, the outer zone is actually not that visible, but if you look at it very closely, you can actually see the outer layer or an outline which is bluish or purplish in color. Middle zone is the most visible zone, that is the luminous zone, which is yellowish in color. And the inner zone is again blackish in color. So this part you will often see it is kind of blackish in color, and this is the inner zone. So that is with respect to color. Now when you talk about the temperature, outer zone is the hottest. It has the highest temperature. Middle zone is moderately hot and inner zone is the least hot. So that is quite surprising, because many people think that inside the center part will be the hottest and the outer part would be the least hot. But it is just the opposite. So this portion is the hottest. That is why when you slowly try to put your fingers, or when you slowly try to bring your finger near the flame of the candle, you feel hot. Because as you approach towards this outer zone, you tend to feel more hot. But you would have seen a trick very common, where people pass their finger through the inner zone of the candle flame very quickly, and everybody else gets amazed seeing that. They feel that the person is really gifted that he is able to do that. But actually that is just because the inner zone is actually not that hot. Therefore, the finger doesn't get burned. But if you try to expose your finger to the outer zone, then it will get hurt. It will get burnt. So the outermost zone is very hot. The temperature is as high as 600 degrees Celsius. Now, this outer zone is called non-luminous zone because it doesn't produce a lot of light, whereas the middle zone is called the luminous zone. So basically this yellowish orange zone is the luminous zone. So this, in the outermost zone, complete combustion takes place. So here complete combustion take place. That is why a lot of heat is produced, because combustion is all about producing heat. In the middle zone, partial combustion take place. Since partial combustion, therefore moderately hot. Whereas in the inner zone, basically in inner zone contains only the unburned vapors. That means no burning is actually happening there. Only the unburnt particles are staying there. So this contains the unburned vapors, and that is why it is the least hot. So therefore, if wherever you see that the flame is used for heating purposes, you would have seen that the outer layer of the flame is being used for heating objects. For example, for melting tough metals like gold and silver. In order to make jewelry out of gold and silver, they need to be given desired shapes. So how do you do that? By heating them. You need to melt those metals. So for doing all these things, the goldsmiths make use of the outer zone of the flame. Thank you. Please visit www.examfear.com to watch more educational videos with a better experience. Please do not forget to like and subscribe to our YouTube channel for latest updates. Thank you once again. Hello friends, this video on combustion and flame part 10 is brought to you by examfear.com. No more fear from exam. So we are now going to talk about flames. So everywhere we discussed about combustion, we found that the result of combustion is either a flame or a fire. So here we are going to talk about flames and how are flames different for different combustible substances. So what exactly is a flame? So it is a hot, glowing, ignited gas during combustion. Now, whenever the process of combustion happens, that is, the combustible substance reacts with oxygen, releasing a lot of heat and light. So how is this heat and light released? It is released in the form of a flame. Now, this flame again differs from one object to another. So if you look at a candle, so the first thing that comes to your mind when you think of a flame is that of the flame of a candle. So if you look at the flame, how does it look? It looks somewhat yellowish to orange in color. That's how it normally looks when you see it from far. So this is the visible gaseous part. It is actually gas. So do you think that flame is a solid or a liquid? No, it is all gas. So it is the ignited gas which becomes visible during combustion. So that is called flame. Now, if you look at the flames from different objects, that is the candle flame or the LPG flame or even the Bunsen burner flame. So all of them, they look quite different from each other. So if you look at the Bunsen burner flame, it is more bluish in color. You look at the candle flame, it is more yellowish or orangish in color. You look at the LPG flame, again there also, your gas oven, the flame there also is little bluish in color. So the type or the structure of the flame, the color of the flame, it varies from one object to another. Now the question is, do all substances produce flames during burning? Now we know that combustion doesn't happen for all substances, but it happens for all combustible substances. Now, is it necessary that all combustible substances will produce flame when they undergo the process of combustion? Let us take two examples. The first example is that of a candle. So in case of candle, when you light the candle, when you bring a matchstick near the candle, it catches fire and you see flames. So when do you see flames? During combustion. So that means candle produce flames during burning. Now let us take another example of, say, charcoal. So what is charcoal? Charcoal is the object which is obtained by heating wood in absence of oxygen. So if you heat wood, what you get is nothing but charcoal. So charcoal also acts as a fuel. Now when you burn charcoal, what happens? Do you see flames? Now in the picture you see, it clearly shows that there is no flame as such. All you can see is a reddish glow, but there is no flame as such. So that means not all combustible substance produce flames, but in this case heat is produced, right? So heat is being produced. That means this process which is taking place here is combustion, but there are no flames. So that means not all substances produce flames during combustion. So the question is, which substances produce flames? Substances which vaporize during burning produce flames. Now what do we mean by vaporize? That means those substances which get converted into their vapors during burning, only they produce flames. Now again, let's go back to the example of the candle. So in candle, what do you think is getting vaporized when it is being burned? It is the wax. So have you ever observed when the candle is burning, the wax is actually being melting. So that means the wax is actually getting, those wax melts are actually getting converted into vapors, and due to the formation of those vapors we are able to see the flame, because flame is nothing but the ignited vapors. Vapors are only being visible as flames. But in case of charcoal, no vaporization is happening. Nothing is, no part of the substance is actually getting converted into vapors. Since there are no vapors, therefore there are no flames. So not only candle, let us take other examples also. So if you take the example of the gas burners, so there also, what is it that is getting converted into vapors? It is nothing but the LPG. The LPG gas which is stored inside the cylinders. So LPG is stored in cylinders with most of it being in liquid form and an upper layer being gaseous. So what does LPG do in order to vaporize? So LPG takes heat from the surrounding environment and naturally reverts to a gaseous state. So in order to vaporize, what we need to do in order to vaporize LPG, all that is needed is just take a matchstick or a gas lighter in front of it, and that's all. So the LPG gets vaporized, and due to the formation of these vapors, we see the flames. That is why you would have observed that if your gas burner, this area, if it is wet, so if it is wet, in that case, even if you bring a matchstick near it and switch it on, but it doesn't catch fire easily. Why? Because of the presence of water. So water will lower its ignition temperature and therefore it will not allow it to catch fire. So here also something is getting vaporized, that is why we see flames. So even if you talk about the Bunsen burner, so there also you see in Bunsen burner, if you have a Bunsen burner in your chemistry lab, please have a look at it. You will see that there is a pipe which is nothing but the gas pipe. This gas pipe is connected to the Bunsen burner, and this gas gets converted into vapors, and those vapors are seen as flames. So wherever there is vaporization taking place, you will see flames, and where there is no vaporization taking place, you will not see flames. So it is not necessary that combustion is always accompanied by formation of flames. Thank you. Please visit www.examfear.com to watch more educational videos with a better experience. Please do not forget to like and subscribe to our YouTube channel for latest updates. Thank you once again.
Combustion. Burning of a substance in the presence of air is known as combustion. When a substance is burnt, it produces carbon dioxide and energy in the form of heat. Some materials are combustible, while some are non-combustible. The materials which burn readily are known as combustible materials. For example, paper, wood, kerosene, diesel, petrol, straw, etc. The materials which do not burn readily are known as non-combustible materials, for example, glass, metals, ceramics, etc. Combustion. Let us do an activity to demonstrate the process of combustion. Take a magnesium ribbon and light it. After some time, you will observe that magnesium burns with a bright white light to form magnesium oxide, emitting heat and light. Now hold a piece of charcoal using a pair of tongs and bring it near the burner. You will observe that the coal burns in air to produce carbon dioxide, heat and light. Thus, in combustion, combustible materials burn to produce heat and light.
Characteristics of a good fuel. A good fuel is one that has low ignition temperature and easily available, has a high calorific value, and is cheap and easy to transport. It does not cause pollution or leaves no unwanted residue upon burning.
Combustion. Let us do an activity to demonstrate combustibility and non-combustibility of materials. Take some materials such as straw, matchsticks, kerosene oil, paper, iron nails, stone pieces and glass. Try to burn each of these materials one by one and observe. You will observe that straw, matchstick, kerosene oil and paper catch fire easily, while iron nails, stone pieces and glass do not catch fire. By this activity we can conclude that straw, matchsticks, kerosene oil and paper are combustible materials, while iron nails, stone pieces and glass are non-combustible materials. Conditions required for combustion. Presence of a combustible substance. The attainment of the correct temperature for ignition or ignition temperature. Presence of a supporter of combustion such as oxygen. Combustion. Let us do an activity to demonstrate the conditions required for combustion to take place. Take a lighted candle and fix it on a table. Put a glass chimney over the candle and rest it on a few wooden blocks in such a way that air can enter the chimney. Observe the flame. You will observe that the candle burns freely. Now Remove the wooden blocks and let the chimney rest on the table and observe. You will notice that when air does not enter the chimney from below, the flame flickers and produces smoke. Finally, put a glass plate over the chimney and watch the flame again. You will observe that the flame finally gets extinguished because air is not available. By this activity, we can conclude that oxygen present in the air is necessary for the process of combustion. Combustion. Let us do an activity to demonstrate that oxygen is necessary for combustion. Take a piece of burning wood and place it on an iron plate. Now cover it with a glass jar and observe. You will observe that the piece of burning wood gets extinguished after some time because the supply of oxygen has been stopped. By this activity, we can conclude that oxygen is necessary to support the process of combustion. Ignition temperature. Take a piece of paper and a piece of wood and try to burn each of them with the help of a matchstick. You will observe that the piece of paper catches fire easily, while wood does not catch fire easily. Now pour some kerosene oil on the wood and burn it. You will observe that this time the wood catches fire easily. By this activity, we can conclude that different materials catch fire at different temperatures. Thus, the minimum temperature at which a combustible substance catches fire is called its ignition temperature. Ignition temperature. Let us do an activity to demonstrate ignition temperature of materials. Make 2 paper cups by folding a sheet of paper. Fill 50 ml of water in one of the cups. Now heat both the cups separately with a candle. After some time, you will observe that the empty paper cup burns quickly while the paper cup containing water does not burn, but it becomes hot because the water in the cup absorbs the heat and distributes it to all the parts that holds water. So, in the presence of water, the paper does not attain its ignition temperature. Hence, it does not burn. By this activity, we can conclude that substances having very low ignition temperature can catch fire easily and are therefore called inflammable substances. How do we control fire? You might have seen or heard of fires breaking out in homes, shops and factories. You might have seen a fire brigade also. Fire brigade pours water on the fire. Water cools the combustible material so that its temperature is brought below its ignition temperature. This prevents the fire from spreading. Water vapors also surround the combustible material, helping in cutting off the supply of air. So, the fire is extinguished. As we know, there are 3 essential requirements for igniting fire: fuel, air, and heat. Fire can be controlled by removing one or more of these requirements. Fire extinguishers. The most common fire extinguisher is water, but water works only when things like wood and paper are on fire. If an electrical equipment is on fire, water may conduct electricity and harm those who are trying to put off the fire. Water is also not suitable for fires involving oil and petrol. For fires involving electrical equipments and inflammable materials like petrol, carbon dioxide, CO2, is the best extinguisher. CO2, being heavier than oxygen, covers the fire like a blanket. Since the contact between the fuel and oxygen is cut off, the fire is controlled. The added advantage of CO2 is that in most cases it does not harm the electrical equipment. It can be stored at high pressure as a liquid in cylinders. When released from the cylinder, CO2 expands enormously in volume and cools down. So, it not only forms a blanket around the fire but also brings down the temperature of the fuel. That is why it is an excellent fire extinguisher. Types of combustion. Slow combustion. In certain cases, we find that natural process of oxidation is quite slow. For example, when iron is exposed to air, it gets corroded and forms rust, which is iron oxide. Spontaneous combustion. There are some combustible substances that catch fire on their own when they are exposed to air. This phenomena is known as spontaneous combustion. For example, sodium catches fire spontaneously in air. Rapid combustion. When a combustible material burns quickly, the process is called rapid combustion. Burning of wax candle and domestic fuel, LPG, is the example of rapid combustion. Explosion. When a combustible substance burns very rapidly with the evolution of tremendous heat, light and sound energy, it is called an explosion. For example, explosion of bomb.
Combustion and flame. Introduction. Observe the flame of the LPG and the candle. Can you see that the flame of the LPG is clean blue in color and does not leave any other gases? On the other hand, the candle burns with a yellow luminous flame, leaving behind black soot or residue. In combustion, the substances that vaporize produce a flame. When a candle is lit, the molten wax rises through the wick and gets vaporized to produce a flame. A fuel like charcoal does not vaporize and so does not produce a flame. Structure of flame. Observe the flame of the candle. We can notice that the flame of the candle has three regions: innermost zone, middle zone, and outer zone. The innermost zone has dark black vapors of wax. In this part, the vapors are not burnt and therefore it is the least hot region of the candle. In the middle zone, the wax vapors start burning. The color of the flame is yellow. Since oxygen available in this region is not sufficient for the wax vapors to burn completely, and therefore the temperature in the zone is not very hot. In the outer zone, the wax vapors burn completely in the presence of sufficient oxygen from air. The color of the flame is blue and the temperature in this region is very high. Innermost zone. Let us do an activity to show that innermost zone of a flame consists of unburnt wax vapors. Take a candle and place it on a table. Now light it with the help of a matchstick. Bring a glass tube and introduce one end of the glass tube in the innermost zone of the flame. Now bring an ignited matchstick near the other end of the glass tube. What do you see? We see a flame at the end of the glass tube. The innermost zone of the flame near the heated wick consists of unburnt vapors. These wax vapors enter the glass tube and come out from the other end. And on introducing a lighted matchstick near the end of the glass tube, the wax vapors coming out of it catch fire, producing a flame. So we can say that the innermost zone of a candle consists of unburnt wax vapors. Middle zone. Let us perform an activity to show that the luminous or middle zone of the flame consists of unburnt carbon particles. Take a lighted candle and place it on a table. Introduce a glass slide into the luminous zone of the flame with a pair of tongs. Hold the slide for about 10 seconds. Now remove the slide from the flame and observe. A circular blackish ring is formed on the glass slide. So we can say that the luminous flame consists of unburnt carbon particles. Outermost zone. Finally, let us do an activity to show that non-luminous zone is the hottest part of the flame. We have a lighted candle placed on the table. Now, hold a thin, long copper wire just inside the flame with a pair of tongs for about 30 seconds. Observe carefully. The part of the copper wire just outside the flame turns red hot. This is the non-luminous flame of the candle. It has a high temperature and is the hottest part of the flame. Summary. A flame is a region where combustion of fuel takes place. In combustion, the substances that vaporize produce a flame. When a candle is lit, the molten wax rises through the wick and gets vaporized to produce a flame. The flame of the candle has 3 regions: innermost zone, middle zone, and outer zone. The innermost zone of the flame has dark black vapors of wax. In this part, the vapors are not burnt, and therefore it is the least hot region of the candle. In the middle zone of the flame, the wax vapors start burning. The color of the flame is yellow. In the outer zone of the flame, the wax vapors burn completely in the presence of sufficient oxygen from air. The color of the flame is blue, and the temperature in this region is very high.